Hello everybody, welcome to another stream. How we doing? Oh, there we go. Hey Lupo, how you doing, sir? Welcome. I was a little bit late because I was getting my son to sleep again. He's not liking his mum putting him down, so he needed daddy to do it. Silly boy. But yeah, baby's down. So what we're working on today, I'll get my laptop up so I can see chat in a sec. We're working on trying to get tons of models on the screen and also tons of ellipsoids on the screen. They're two different things to test. So we'll make something to easily configure that. So we're not just writing code all the time, just write the code once and just tweak some UI. And we're trying to make it fit into about a 4 millisecond budget, because I think typically in renderers you have about a 4 millisecond budget for rendering geometry, and this is what it is doing at the moment. So we want to do the geometry rendering and just make sure it fits into 4 millisecond budget. We're currently rendering at a higher resolution than 1080p, and we're on about a mid-tier card. So I'm thinking if we can do it for that resolution, that would be awesome. But if not, we'll fall back to 1080p on a mid-tier card. And then we're probably going to be doing this for a couple of streams, because we also want to be tuning the occlusion buffer, because this is the thing which is going to get us all of the speed, I think, because we'll basically be culling stuff we don't want to render. And there'll be other aspects of the render as well, which will be bottlenecks. So we'll probably want to disable some parts of the ray tracing shader to see, like, hey, which parts of the, is the material shading that expensive? Is it the amount of objects that we're looking at and stuff like that? So we're really gonna try and do a little bit of performance optimization as well, and around the testing, obviously. Right, how's it going? I'm doing bad, thank you. Had a good sleep last night, so I caught up with the sleep on Tuesday. Was it Tuesday? Yeah, on Tuesday I wasn't feeling that great because I was pretty tired. But yeah, feeling better today, thank you. How about you, Lupo? What have you been up to? How's the week going? Oh, and I hope everyone's having a good week so far. Got me a Pepsi Max, as usual. So, we're going to start. So, let's just see the game first, for those who haven't seen the game for a while. We have currently, we're using the entity system to, oh yeah, we made these. This is really cool. We did this last stream. So, we've got transparency with up to 4 layers. Well, sorry, 4 layers of objects per pixel. So it seems like there's more than 4 objects here because you've got a background one there. But when you see the light at the back, we'll see the lights, and they hit the objects at the back, you see the back one disappears. So actually, it's per pixel. So yeah, we've got like 4 layers of transparency. They also properly order and everything, so there's no glitches there. They can overlap and there's no problems. So it's proper cool. We got that done last stream, and we got the ability to sort of go in. We sorted out the near clip thing as well, so they don't disappear when you're outside of them, but you move the camera. Now they disappear when you go inside them. That's another bug to fix if we want to fix it. So yeah, that's what I was working on last stream. So I'm happy with these transparent renders. And these are all spawned with the entity system. So we've got, oh, the occlusion buffer is still failing, great. Anyway, we'll look into that today, I guess. So this is also spawned with the entity system. If I take a look at the performance, we're about, so for a full screen, we're about 3 milliseconds. Turn off the occlusion. Yeah, we're about 3 milliseconds. Or 4.4 milliseconds for a full screen's worth. So what I'm interested in doing is, can we we'll make some little bars of UI, and we'll be able to essentially up the complexity of a model. So we'll do a 2D grid for the model, and then we also want to be able to up the complexity for how many models we have. So we'll have essentially an array with two hierarchies. The outer hierarchy will be the model instances, and the inner hierarchy will be the model. And that will allow us to scale up and test model instances and number of ellipsoids with just a couple of UI bars. So I think that's what we'll focus on first, and then we can worry about what's slow and tackle those things piece by piece. Maybe build in some debug UI stuff, you know, things like that. Have I told you about my laptop? No, you haven't told me about your laptop. So I got a laptop from a I got back my replace from you got back your laptop from a repairment service. It was making a whistling noise. Now they made it worse, and the noise hasn't gone, and the thermal throttling. Ugh. Crazy. That's sad to hear. Well, yeah, so it's too hot, so it's losing the performance, isn't it? Yeah. Wow. Have you tried cleaning out the fans? So doesn't the whistling noise come from the fact that I forget exactly what it is, but basically the solution is you've got a fan and it's clogged up, and I think is whistling because, yeah, I forget the reason why it's whistling. I can't really comment on that. But you've got to basically like clean your fan out. If you tried taking it apart, because the fans are quite exposed, aren't they, typically? So there's not that much you have to take off. You just need to make sure you've got the right screws and you're careful taking it off. You know, put enough pressure down when you unscrew it. Stuff like that, you know. But yeah. It's basically a new brand, lol. Use it for like a month, maybe even less. Wow. Do you not have warranty on it? The reason I submitted there was because that is still on warranty. Right. I see now. Yeah, so I guess you can I guess you just got to take it back to them, and it's super annoying though. This is annoying. You got to take it back to them and say we didn't fix it, and then just say like, you know, ask them see if they can actually fix it this time. Because, you know, people do make mistakes, and that's, you know, understandable sometimes. But if they do it a second time, you've literally just got to ask for your money back and take your money elsewhere. Yeah, or maybe ask for a replacement first. And then ask for your money back after that, if that fails. Yeah, because you might generally like the laptop, then replacement. Hey Voodoo, how you doing, sir? Right, so I want to add a piece of UI. So we've done this before. We've done like a slider, right? Well, I've not got the code around anymore, but that's okay because it's just UI code. It's not too bad to do. Now there's a UI frame end that's dotted about. Oh, well, have I done a UI whatever? Okay, so around here we're gonna, you know, do our temporary piece of UI. So this is just gonna say, so I guess we got a UI rectangle. This will be the, let's call it rec, as you do. And this will just be the UI window rectangle. So just take the full screen window as a rectangle. And that's just the thing we're gonna cut up and make into UI. So we're now gonna, like, I guess make another rectangle called A, because This is temporary code, and we're going to say cut from the top, please, by some amount. And that amount might be 20. Maybe 20 is too much. Oh, maybe it's not enough. That's what I meant to say. Words. Let's do 40. Or okay, let's put in a variable because we're going to be doing it a couple of times, I think. Let's change that one. Alright. Then we probably, like on the top left hand side, there's going to actually be a piece of white text where when we open up the profiler. So what we should probably do is do a UI cut center horizontal and then pass in like an amount of like say 200 pixels, or times by DPI, but there we go, done. So that's gonna center it now, so we've got a box which is centered at the top. And then we're going to simply just say UI I think we want to make another cut, not gonna lie. I guess we'll call this one B. Because it's just temporary code, there we go. We'll cut to the left. Follow width too, because we've already got one called width. And then we'll just simply say, right, we've got a piece of text, bit of C text with a B, and we pass in the strings. This would be like the number of models. And maybe we can actually pass in some kind of, let's have a buffer. That'll do. Sn printf buff, size of buffer. So models and we'll have like a number of models here. Maybe to think about changing the slider, because the slider should also tell you the number in a nice way. But yeah, we'll just have like a number that's sort of put out here. So we'll just say, okay, it's this is where the fun begins. So we say models count. Now you can never have 0 models. So let's say there's 1. You can have 0. Now this should probably actually go. Oh no, it can't go near the model code. Crap. Right, we'll put we'll make these global. So we'll put them out in the global scope because my other functions are going to need to access these. And I'll have another one called inst. So that's the number of sort of like instances. And then this will be the number of ellipsoids inside each. Inside each model. So we'll just be able to grab this nice piece of UI and be able to simply just change these values and test scaling and descaling. The amount of objects in the scene in a very easy way. So align this one to the middle left, I guess. And then we'll do style of address of UI. We don't want a box. Alright, so I think. Oh yeah, then we've got one more. UI slider integer please. And I'm going to pass in the A box. So the rectangle was passed in. Then I'm going to pass in the values G models count. Start will be 0, I guess. Probably 1. Let's say 1. And end would be. So we're just going to make it 2-dimensional. Both of them. No, it might be 3-dimensional. What's the thing about it? Oh, it could be. Maybe it could be the count squared, and we'll actually put stuff behind it as well. That'd be interesting. So, 64 squared. What is that? Right, it's 256,000. So that'd be great. Sorry, I meant to say cubed. 64 cubed. So with 64 cubed of models, we can test up to 250,000 models. And then it would also test up to 250,000 ellipsoids as well with the difference slider. Bearing in mind, so we have. Yeah, and it just scales in a cubed fashion, which I guess is okay. So I think let's roll with that. UI style no box, okay? So now we simply just take this, repeat it, and then we simply just replace the 2 lines which have the word model in it, basically. Oh, come on. There we go. Nice, so now we've got our UI there. We just want to make these more globally accessible, and then we can go ahead and start writing the code which actually spawns these objects. Render mod. Right, upload model instances. Yeah, I guess we'll put it here. We might write more in the payload. Yeah, I think we'll just simply write after the memory in the payload, and then that should be enough. So I think I'll disable anything. Like, I know I've pre-allocated the buffers and they have enough room, so we should just be able to write to the memory afterwards, and for debugging, that's perfectly fine. It's supposed to be a simple fix. I was content with the laptop overall. Yeah. Hello, just finished my job project and super tired. That's cool. Awesome though. It's great to finish a project. How's it been received? Have you showed it off yet? Okay. So what I'm thinking about doing is, let's say, put this in a scope so we can delete it. Or, we'll delete it easier. Let's say payload model instances dot count is equal to 0. And now, so we don't care what the game red gave us, or the game side code, and we're going to just put in our own stuff. So I think we can just say, okay, well, so we do a Z, ZYX, and now we just simply See, I hope I got enough actually thinking about it. I don't know if I've allocated enough in this array. Let's take a look at it. Wait. Payload in it. Yeah, what's the capacity for that? Oh, it's not enough, is it? So let's put a good old big number in there, you know? Let's put... Should we do like the million? Oh, for crying out loud. Why can't you just get what I'm saying? Do like a million in there. I want to do it. I could have just done one shift left 20, but there you go. I wanted to write it out. Done. So, the next power of 2 up from a million. Right, so now we've definitely got room. So we're going to get the graphics. But I don't know if we've got enough room in the GPU. We'll find out. Payload, model instances, data. Now we're going to get the sort of index here by making it flat. Oh, I've already got a flatten function, have I? I could use Morton code. So we want to take a 3D thing. So that be between 0. Yeah, 0 to 1 in it. So we do a divide. I think at 1024 it goes up to. So we should be able to do a X, Y, Z, and then divide this gets us a flat index basically, but as in the Morton code and in the Z ordering thing. And then we, because I didn't have a function which flattened out a 3D index. So we get that. Now we say M. You're gonna get holes though, isn't it? It's always going to be square, so it might be fine. No, it might not be. Sorry, by square I meant cubed. Yeah, we're going to have to... Right, let's... See, I've done the maths before in the past, actually, but I've not written a function for it. So, yeah, let's make one of these, because they're going to be useful. Flatten. You know what, I've done it in the entity code. So, here. Yeah, it's this. It's the number of z's times by your number of Z layers times by the slice, by the dimensions of a slice, so the X and Y, yeah, something like that. So I want to make a function for this because it's quite useful. So I've got one called flatten for hashing, but that's not what I wanted. So it's mainly about coordinates and stuff. We kind of want some other sort of general maths ones. I guess I can stick it here. But yeah, so static, inline, flatten, 3D. So you take in an X, Y, Z, and then you're taking the dimensions. Now you only really need the width and height, to be honest. Right, so the 20th is the deadline. Nice. It's a new project, the code will be done. But I need to also make documentation, right. Have you been following the stream for 4 years? And how did Lupo know that? How did Lupo find that out? Hey, Dal, how's it going? Oh wait, Delhi. I saw her name in the chat, right. Okay, it tells everyone. Interesting. I thought it only told me. Good, thanks. How are you? Good, that's good, man. Yeah, I'm not bad. I've got some good sleep, so I'm feeling better. Yesterday it was bad. I was so tired. I actually took a nap. I was saying to my wife, if I'm going to be going to church, I need to take a nap, and she said, "That's okay." So I got to take a nap, which was great. So after dinner, I just sort of laid there in bed and got an hour's nap, and I felt much better. Then I got a reasonable sleep as well, which is good. So, yeah. So make an unflattened function as well. This one's quite useful for you still need the dimensions. Yep. So to go the other way, oh, I forget how you go the other way now. So there's the mod. Yeah, I guess let me do the 2D one for a minute and I'll remember. So flatten 2D. is coordinate width. Plus the x jobs again. Unflatten. And you pass in the width again. Right, so the unflatten is, so to get the y, it's the mod. Is it? X equals, yeah, one's the division. That would be the, yeah, so x mod would be, yeah, sorry. Index mod width would be the x and the y would be divided by, and it gets truncated, right? And then so your return is just this. Now, to do it in 3D, it's just a little bit more of a pain in the butt. You need the width and the height. So just got to think of that slice, because the slice is the, while drinking, yeah, Pepsi Max. You know, I play around with different flavors of Pepsi Max. You know, the cherry's quite good. I quite like that one. On the standard Pepsi Max, it's also a very good flavor as well. And then the other one's the mango one. It's pretty solid. But what they're keeping from us, the general public, is Pepsi Vanilla. And it's a crime. If you go into Pizza Hut, they have a machine. And you can select these different flavors. And I know there's like the lime one, but the lime one's, in my opinion, it's quite, it's not nice. But they've got a secret flavor, and that is vanilla. And yeah, you can sort of like select it and pour out of the machine, and it's just so refreshing. It's so good. And I remember last time I went with my wife to Pizza Hut. I went up to that machine and I was getting myself some. I think it was like my third glass of Pepsi Max Vanilla, and this little kid came up next to me, and I just said, "I, I basically said to him, this Pepsi Max Vanilla is like super great, isn't it?" And he's like, "Yeah." It turns out he was getting the same thing as well. He was onto how good the Pepsi Max Vanilla is too. It's quite funny. What a boy. You know, the kids know. Having kids seems hard on sleep. Yeah, you know, it's not that bad. It's just you get the odd one where it is, like when they're ill. You know, when you it's all about like make sure there's a routine and just being sort of, you know, make sure they're in a good mood. And when you put them to bed, you know, make sure you got this sort of like routine that you follow every day, because then you like uncertainty. But you can't really get away with it when they're ill, obviously. So you've just got to, yeah, deal with those consequences and see what you can do to help. You know, get Calpol, get ibuprofen, and yeah. And if you have a wife at the same time, obviously you can tag team it and share some of what's going on. Becomes it easier. But I typically do the early mornings. She'll do overnights. Currently, last night my daughter with a small stomach bug, 1 a.m. And the night before my son. Right, so you got two of them. Yeah, so twice the potential. Just wake at 3 a.m. juice to the full moon, I guess. Oh, Yeah. Yeah, I haven't necessarily needed the naps, but I think, yeah, it's just that time. But yeah, I haven't got a second one yet. We've been trying to get a second one. Unfortunately, we had some bad news last week. So we've been going through that. We had a miscarriage at, well, it wasn't a miscarriage. The baby was dead at 7 weeks. Well, it died at 7 weeks, but we was checking at 11 weeks. So yeah, we've been going over that the past week and sorting out all that. But yeah, it's been the second one we've had in a row. So hopefully next time, fingers crossed, we'll have another one. But yeah, it's really cool. Children are the best. Lime Pepsi kind of has a toothpaste. Yeah, it's I don't know what it is about it. It's not refreshing. It's kind of like bittery, I think. That's the way of putting it. Yeah, in the UK they recently started doing the mango flavor. Very recently. Good. My wife calls it an abomination, but that's because she eats actual mangoes. Get them to us there, they're awake like an hour earlier. Right, yeah, yeah, they do that. It gets them upset, doesn't it? Yeah, that is it. We have a local drink called here called Gracio. Really, really good. What sort of flavor is that? Let's have a look. Gracio. It sounds like it can overlap with lots of other things. Oh wow, that was posh, didn't it? Maybe that's not it. Wine-based beverage. Maybe this is not it. There's a hot chocolate one. Is it a hot chocolate drink? Or this one, a lemonade. Is it Spanish? Lee. No, maybe it's not Spanish. Oh, Kazakhstan, right. Gotcha. Oh yeah, I remember you saying that last time. There's champagne with green coffee. Something else. Right. The first pick. This one. Huh. Huh. Sounds very, very natural. That. Oh, okay, the other one. Yeah, yeah, this one on the left. You find that a lot in other countries. In the UK, things are so artificial. I don't. Right, I think I can be on this one. Don't have to like dox my address or anything. Yes, you find that in the. Okay. It's like a tea and fruit drink type of thing, right? Like a cold one, like an iced tea. I've not really had like an iced tea, to be honest. Yeah. Well, the thing about the UK is whenever you get any of these drinks, they just have so much like they're just so artificially tasting. Like there's an artificial orange flavor, there's an artificial cherry flavor, there's an artificial, whatever flavor. Whenever you go to a foreign country, if you pick up like a Fanta, the orange actually tastes like a proper orange. Like the flavoring is just more natural tasting. I don't know how natural it actually is, but it just tastes more actual like the fruit. It's in like Spain and African countries as well that I've noticed. I would just assume it's all European and yeah, more tropical places. Lemonade one non-alcoholic, yeah. Don't know why those includes one at the top. There we go. Right, so unflattened 3D. So the reason why the unflattened 2D works is because you're basically saying divide by that and you get the row, and mod and you get the row, and then mod you get the column. Now that doesn't necessarily work. So it'd be divide by the slice. Yes, you need to be able to get like, what is the, give me this sort of like slice. Give me the sort of index within a slice, basically. So you want to be able to say what is the sort of slice pixels count, and that will then be the dims.y times dims.z, and then with that, no, x times y, of course, and then with that you can use it to say, so then because it's a slice, that's basically just a 2D image, so then the same method for the 2D will work with this one. Oh wait, sorry, crap. You've got to get the sort of slice index relative index from slice, and that will be index mod slice pixels count. I think you can just use that. Then I think the Z coordinate would be the index divided by how many pixels in a slice. I think that's right. Might be a bit wrong with that one though. Remainder within a slice. Yeah, that's right. I think that's right. We'll find out in the future. Future me will maybe trip up on this, and then he'll blame past me, and then yeah. So I wanted to do this just so I could have this function here, basically. Flatten 3D, pass it a coordinate being XYZ, followed by some width. So etho2 G models count, so done with that. Right, so that will get us an actual proper index. Now we don't have any holes. Now we can just basically, right. So the path hash, we don't really have a path hash at the moment to refer to an asset, so what we're doing is just passing in some hard-coded thing. So this hard-coded thing, we're going to say, well, if it's the, we're doing null or whatever. I don't know. It's just temporary code, right? Wild from local, good point. What is this? So perfect. So we say translation. So given, so the way that I look at it is what we want to have is based on the number of ellipsoids, and that will give you like a width, height, and the problem is that's going to get quite big. And that's fine, I think. Maybe we can scale it. Maybe we can just change the scale. But yeah, the basic idea is translation. Oh no, I can just say like this, isn't it? So what we can say is like, well, based on the number of ellipsoids. No. Oh, right, you can take the xy multiplied by the number of ellipsoids across each dimension. And that's what we do for now. Yeah, this won't be an S, will it? And then the scale should just be, we could say 0. Let's make it really small. Wait. Let's say 0.5 for now. We can always just change it. Across each dimension. And then obviously the rotation will just be identity. Identity quaternion or quaternion identity. I've got to change that around, but there we go. Right, so that's just going to spawn all of the models that we want. Now we have to do the same sort of code when we try and get in this sort of model find or load, which is going to go, hang on a minute. You're looking for a null model ID and it hasn't been set up this frame, then generate another thing like this where it's a 3D grid of ellipsoids, but for the model instead. So there's 2 layers of this thing going on. There's a outer one which is a cube of model instances, and then inside each cell within that grid there's another grid of ellipsoids, and that's what we can do to scale up and scale down those 2 properties, and it'll be a good test case. Well, I think it'll be a good test case. We'll find out. We might need another slider to decide spacing or something, but let's just roll with this one. So if the model is not loaded into GPU memory, so I probably just want to say this, right? Let's just not change any of this code because it's a bit dumb. But we should probably say, like, how do we know what frame? Alright, let's just say, because I can't be asked to think about it. So we go, okay, if G models count is not equal to models count, well, we're just talking about if you change the ellipsoids actually. So if that's not equal to that one, all we're going to do, now let's go back and find that G models count again. Let's get this 3-dimensional thing, and we're basically going to do the same thing here and initialize what's known as model ID. So we want to allocate a, we want to be careful because you could, well, all we care about is the upload, isn't it? That is true. So we could just get going with the upload basically. We don't have to care about using the allocator. And we do want a destination model, and we do want to return some kind of model ID, which could probably just be 0. I think that'll work. Okay. Oh, I deleted the static thing. What a melon. Yeah, we have a janky tasting ones too. The brand is game changer over here. Relatively too. Right. Awesome. In Germany, I started using the syrups and sparkling water soda. That way I can have it like I want. Ah, clever. Yeah, that is the way around it, isn't it? Just get the flavorings yourself and make whatever the crap you want. That is very true. That is smart. Hmm. One can costs $1. It's quite a lot of money, isn't it? I think can's about 50p here, which is about basically 50 cents these days. If you do a proper conversion, the pound is still worth more, whatever that means. But it was nowhere near as good as it used to be back when I was a boy. So we're looking at basically filling up. So we want to allocate. So open up the upload buffer. Destination ellipsoids. We'll get in there. We're going to start at 0 in bytes. G ellipsoids count. Make sure we say ellipsoids count equal. Gotta be careful here. Yeah, I think I got shadowing on, so it might not be a compiler error. I only turn that shadowing thing on. I hate shadowing. So here we're going to get access to the actual ellipsoid and then write out. So DST ellipsoids. And then write out what we want. So we need to write out the model from ellipsoid. That is this code here. Bearing in mind we need to write it in unsigned norm. Sorry, signed norm space. So, okay. We want to take the, we probably want to, yeah, so you want to take your X, Y, Z, and then divide that by G ellipsoids count. So I'll give you a value between 0 and 1, which is unsigned norm. And then you need to do the multiply by 0.5. Wait, is that right? No. That's the other way around, isn't it? Times by 2. So now it's 0 to 2. And then take 1. Cool, so that puts you in signed norm space. So the only thing now you've got to control is the scale. The scale's got to be based on like, well, how many do you fit across the X, Y, and Z axis? It's just a cube we're doing, right? Little grid. Well, a scale of 1, you only have 1, isn't it? So I think the scale will just literally be by the number of ellipsoids. And that should be it. What else are we missing? So alpha, let's just say they're always opaque. And the other one is the material index. We're not really using that at the moment. That's something we're going to do kind of soonish. Next month, we'll do multiple materials and stuff like that. Be great. That'd be awesome. But until then. So the idea here is we're... Right. So I think we've got to be careful. Yeah, we can output 0. Yes, I think we'll be able to output 0 here. So we always want to... So if you're the first one to happen, and you haven't uploaded it... Ah, crap, I didn't... I deleted this code, didn't I? Make sure we upload the model to say where the ellipsoids start. So on GPU, they can get the range of ellipsoids quite easily. Also the ellipsoids count, good. And the model index will just be 0. Good. Right, so I think we've got it all in there. So I guess let's just give it a run and see how it looks. So we're just basically generating a 3D grid with 2 hierarchies. Is that the way it name? 2 levels of detail. I don't know how you want to say it. But the outer one is the model instances, the inner one is the number of ellipsoids. Right, so we've got 2 lines here. They are doing absolutely nothing. And there's some text on the left-hand side of the screen. So the UI is completely messed up. I don't know why. What did I do? Cut, centered it. Right, B is not the right rectangle, is it? It's not using the right rectangle. So now it's going to get the actual text in the right place, I think. Well, I didn't cut enough for the width. That's understandable. Did I start them off as like infinity or something? What did I do? No, I started off on 0. So what's wrong with that? Oh, I'm using the no box style, I think. And I think I need to use the box style. I think that's it. Because that made it such that the... I don't know, there's something wrong with the style. But yeah, the width we need on width 2 is probably, let's say, 100. And then let's say we'll cut up 300 then. And hopefully that's a working UI. Cool. We need a little bit more width on there. So on width 2, let's say 120. Yeah, 133 if you buy it by itself, but you can buy it in packs and it's much cheaper. Oh, is it cheap? Right, is $1 is that cheap for a soft drink over there? Oh, it needs more width. Let's say 150 then. Right, let's make this 400. Right, so now with these 2 lovely sliders at the top, which help us generate tons of ellipsoids and models. So right now we've got none, obviously. Let's take a step back. I can't see any. What a bugger this is. Well, they are nowhere to be seen. So, debugging time. Well. Did I not change the number of models when I hijacked the model upload code? I think that was it, right? Yeah, okay. Good. So I didn't change this to be G models count, right? So yeah, what we've done is just hijacked whatever the game gives us and be like, no, this is what it is now. And writing our own stuff in there and just stomping over memory like a boss. So here we go. Oh wow. Was it 3 times 3 times 3? It's like, was that like 27 or something? Wait, 3 times 3 is obviously 9. Times 3 again, it's 27, isn't it? Yeah. So 27 ellipsoids in a thing. It's like, maybe it's a bit too aggressive doing these things. Maybe let's be a bit careful with the UI. And let's just limit it for now to like 4 by 4 by 4, and we'll just change it in a bit, right? So the thing is then, right, let's read over this code again. So we upload, are these big enough? That's the question, right? Number of models, well, that's not enough, is it? Let's do 1,000,000. What was that number again? That wasn't copying. I'll do it. Let's get this music back as well. Where's my music gone? Right, catch you later, Lupo. Have a good one. Good to see you too. So we've got a maximum of about 120 ellipsoids per instance, and that's okay. Yeah, because I don't think we're going to have a lot of ellipsoids in an instance. Because there's going to be like characters with like customizable pieces, and those are probably going to not have that many. But you could have, and I think we might have buildings made up of tons of little models, maybe like tiles or something. So I think we're actually not going to have that much complexity in a model itself. So yeah, maybe we should just test out, stick to that basically. So what's going on here? So I guess what I can do is print out like, hey, this is the model index, and we can just, we just write this function, right? Let's just double check it, make sure it's all good. When we up such as the model, number of models, right? So there you go. That looks alright. It's a linear sequence there. Cool. So we're fine with the loops. Loops are good. Translation is times by number of ellipsoids. Yeah, we wanted that, right? Okay, so we're filling all those in. And then what else goes on? Then it does that find all load thing. And we just hijack it. And it points to 0. Now maybe the 0 index is not really used. Is that? No, it will be used. Model instances count. Where do I get that? Right, up, isn't it? It's an insert. Good. So we're just going over and bump allocating them, but we can always choose to skip if it's not loaded yet in the future, right? That's why it's written this way. So you can have a 0 model index, that's fine. So I guess I'm just a little bit concerned on we don't use the models in anywhere before that. So in this final load then I guess it's something to do with this. So ellipsoids count. We're uploading that many ellipsoids in, right? Good. We go over the XYZ, yep. Right, maybe Yeah, so that would have flattened okay. Destination. Alpha of 1, yep. So divide by that. Yeah, that's right. You probably do want to offset this by 0.5 if you want to make it perfect. But it might be good just to see. No, I think it won't really matter for this test code. Right, so you times by, let's get your value kind of between 0 and 1. And take 1. So you get your minus 1 to 1. Right, scale. Ah, shoot, the scale's just damn too big. That's why it's a problem. So you actually want the inverse, I think. Right, so the width of it is 2 in sine norm space. Is that right? I think it's just 1. Yeah, that'll be it. So I think that was the problem, is things were just so big that it actually became, I don't know. Ah, they're right here. Right next to me. Right, here we go. Right, so clearly seeing something. But we're only seeing it across an axis. The x-axis. Why are we no see across many axes? That is a good question. So, the model's 1 doesn't go across many axes, just 1. And the ellipsoid also goes across one axis, so something was wrong in both of the code, right? They've got the different z coordinates and stuff. This is silly. So it's only for both of them, which is super bizarre. Like, why? So we could swizzle the x and y and be like, does it go down the other dimension? And is it just, or up the other dimension, right? And is it... Yeah, so it's able to go up the other dimensions. It's nothing to do with like going, like increasing that way, is it? You know? So what's the problem then? I'm such a melon. This needs to be cubed. Because I'm using the count to mean actually it's a single dimension. Okay. Right, so I think we're there. Just got to go ahead and change this one here. This is now cubed. And then this should be our debugging tool ready to massively expand on the scene. Right, I might want to move the camera back a bit. Cool, bit too much spacing. I thought Right, so yeah, the models one emits 3D. The ellipsoids one does not emit in 3D still. And there's also a lot of spacing between the models. A bit too much spacing. Don't know why that is, to be honest. Oh yeah, because I did times by that. It's completely dumb. More, well, no, it's maybe not that dumb. It's because I could have... Yeah, I think that's okay. I wanted to maybe make the model grow if it had more ellipsoids, but let's not do that. So yeah, that did not really work in the... Of course. This also needs to be cubed as well. I didn't upload enough. That's the problem. And there we go. Awesome. So we up that to something and then voila. Tons of ellipsoids. This might look similar to what we did in the past, where we'd had these sort of cubes of spheres. Now we get to see them again. Right, so now I think we can just up that dense thing. So we had some problems there with the occlusion buffer. Got to sort that out. I think I might do a little bit of a trick where we can test if it's sampling or not. So we bring up the... So full screen for... I don't know, how many is this? 4, 8, 16, so 16 cubed. Right, so 4096 on a screen is about 4 milliseconds. But yeah, it's testing all of them, even the ones in the middle, because I disabled the occlusion. Yeah, so we're gonna make this... Yeah, we might put a bit of spacing between some of these. Some holes, because... Yeah, I think we'll make it such that there is at least one ellipsoid gap or something. But also we want to make it such that... Wait a minute. I want to make them big enough such that they overlap. Is that what we want? Yeah, then maybe leave a gap. So... Maybe we take away a half? Wait, it's the same as dividing by 2, isn't it? Yeah. Okay. Then we want to make sure that there's probably one gap at the end. So we can see the difference between where the model starts and where the model ends. I think that will do it. Oh, well, that didn't do it. There's definitely overlap, I can tell you that for sure. I don't know what I did wrong. So it definitely made them bigger. And I guess the gap wasn't enough. We could just leave the gap. Or does that make them go past the edge? You need to do an add one if you want a gap. Oh, this might make them squish a bit more together actually, and then it'll create a gap. I think that's what I want. Right, so it's a 2x2 of models. Perfect, alright. Yeah, okay, that's what you want. So it does end up creating some kind of gap, except when it's like 1. I think that's okay. We're not going to be having that many. It's not the most perfect code, but I think I get what I want. Now we can just up that. There we go. We do see some sort of holes there. Maybe we can up it by a half. But I just want to see that gap. Yeah, we've got some glitches here. Cool. So I think it's what I want. So we can now probably go about and say, yeah, maybe we up by a half. That might be a bit better. And then I can say, right, go to here. Go to that. And then go to that UI where these are configurable. And say, right, lap 64 of those. And then probably, so 4x4x4, 64. Yeah, we've got a limit of 128, I think. Yeah, I think 64 is probably enough, so just keep that to 4. And we'll make sure we instantiate these to 1, because why not? No. It's silly making them go down to 1. Gotta go, sleeps for these days. Have a good one. Thank you, Sorry, Deli. Delil. Thank you so much, Delil. Have a good snooze, and I'll see you in the future one, hopefully. I need to zoom in on this and maybe close the other bar because I cannot see things. That's one thing when I started programming that there wasn't really much into. I wasn't really much into it. Technically, I started in middle school, but since I wasn't that much into it, I wasn't learning that much as time passed, and I was more exposed to programs. I started doing more, and especially in uni, and I started being more interested in it, and my productivity rose, and programming became more rewarding, and the more I knew it, the more interesting it was to me. Yeah, that's very true. Like, yeah, no, that's not what you're saying. So it's like that, right? So you have like, when people are like, oh, I don't like maths, right? Is a prime one. I didn't really like maths at school, but when I sort of like started programming, I learned bits of maths while programming. I was like, oh, that's actually quite interesting, right? And especially when I've been doing more sort of like 3D graphics and had to sort of learn more maths, it's the field of maths I've got more interested in learning aspects of it, but I wouldn't say I'm as hooked as I am with programming about maths, right? Nowhere near that. But yeah, like some things you're, I guess, to say naturally less inclined to, whatever that means. Probably like at this point in time, you're not that interested in that field. But when you get more exposure to it, you start to really realize actually it's quite interesting, and it's probably like that for a lot of things. But imagine there's some, fields of, let's say, education, which you might not ever be interested in, or it might take a lot of work to get you interested in it. But yeah, programming is cool. It's very powerful. It's very deep. There's so much stuff you can do with it, and you just gotta find your niche. And then when you start digging around in your niche a bit, you realize, hang on a minute, there's actually these other areas which are interesting too. Right, so how many is that? I should really just get a total number of ellipsoids on screen, right? Because this is not... Oh. Well, we found a crash. Yeah, I know what we did. We filled up the number of ellipsoids, I think. Yeah, the number of tile bin entries, we filled those up. Right, I'm just gonna take a quick break, and then when we come back, we'll look into that problem. We fill up the sort queue, or the sort. Basically, there's a maximum number of things we can sort and fit into screen tiles, and those, yeah, and that means we just overflow the sort buffer or something like this. We do it on the GPU, so it's gonna be a little bit tricky, but I think we can sort it out. Right, BRB. Right, welcome back everybody. Sometimes you need to put work in to get interested in something. Yes, that's right. Yes, very much so. But some things you're really interested in from the get-go, you're like, that thing's so cool. Like, I think if I knew that maths could help you make video games when I was in school, I might have taken more of an interest. If someone just told me like, oh, the dot product can be used for this. All right, we witnessed a crash again, so I have a high suspicion it is to do with that. So, we sort our ellipsoids into screen tiles, right? AMD GPU compute shader crashed. Yeah. Right. So you see this number is getting up really high. It's like 1,000,000. Yeah. Well, that's because we've got a limit of like 1,000,000, I think. I don't know. Maybe I made it 16 million. I forgot it was. But, you know, when we render these ellipsoids, what we do is we simply just take a screen space bounding box around it. It's a very rough one. It's not the best one. And we then sort them. Oh, shoot, don't do that many. Yeah. So we get on these ellipsoids. We get a nice screen space bounding box around it. It's very rough. It's not the best. Does the job. And then we, for every single tile, which is 16 by 16 pixels, which is actually very small, especially on a 4K screen, we duplicate a reference to that ellipsoid along with another 32-bit integer, which has the sort key, which has the tile index in there, along with the depth of the bounding box in view space. And then, so that's what, if we pause and zoom in, this is the obviously profiler. There's the ray tracer, off it goes. Here's the sorting code going on here. We are currently sorting 170,000 objects. But there's not 170,000 objects here, is there? No. So again, we duplicate a single one, however many times it goes over a grid entry. And that code actually doesn't take that long to execute. That's pretty quick. It's one of these shaders here. Tile bins. Why is it calling the setup one? What are you talking about? There you go, splat 16, right, splat optimized for 16, 64, 256. There's the 256 plus. So these ones, ellipsoids that need to be duplicated, or the references for those need to be duplicated more than 256 times. As that takes 0.01 milliseconds. That's not that bad, right? The bit that takes the time is the sorting of all these objects. And so this is what we want to try and minimize, is the amount of objects that we sort. So we might need to opt for bigger tiles, and we might need to opt for better occlusion culling, because those things will help us reduce the number of objects substantially. If we increase the size of a tile to 32, it then means we have 4 times less objects on average to sort. So you should essentially get 4 times better performance. Maybe. There's also other tricks we could do, I guess, but there we go. So then it does the sorting. So it sorts it all into by tile, then by sorted by tile, then by what else? Yeah, then by depth. It's a rough depth because it's the view space bounding box depth. So it's not the actual correct depth. So we still have to sort in a per pixel manner, but it's a much easier algorithm. And it means we can early out with the rough information as well. So it's worth it. Then we find the ranges of where each tile starts, and that's pretty quick as well. So the problem is our sorting buffer only supports up to, I think it's 16 million or it's 1 million. I forgot what I put it on. So the problem is obviously on the GPUs we decide how many, we dynamically generate the amount to sort based on how big the things are on the screen. So when they get so big and they create so many elements, then it overflows that buffer. So what we need to do is, in our splat shader or something like that, we need to make sure we put some overflow checking in, right, and handle that, you know, and then it'll just, you know, be as safe as Rust. It'll be beautiful. So in the splat objects code. I'm just using the one that AMD done because I didn't want to bother writing it. Parallel sort, it's a radix sort. So it sorts 2 bits at a time. So there is potentially an optimization we could do. Sorry, it's 4 bits at a time. AMD parallel sort, I ported it to my shader compiler. So just it sorts 2 bits at a time and sorts, or 4 bits at a time and sorts those. So it calls it like every time there is 4 bits within the integer that you need to sort. So it's a 32-bit integer, so it calls it 8 times. It goes over all the data 8 times. Well, refetches the data from main memory 8 times. Now, or maybe not main memory, it probably goes through a bit of cache depending on how big it is. This is what my render is inspired by, is this thing. But the problem is, so one of the optimizations you can make is if you only need to sort, if your sort key only uses 16 bits, you can half the number of invocations because the high bits won't need to be sorted. So there's an optimization there, but we actually use all 32 bits and there's no way to shrink it. So there's that. Maybe we can get rid of 4 bits if we're lucky. There might be some hacks we can do. But yeah, that would be a bit of a squeeze, I think. Right. So there might be a couple of places where there's a problem. Calculate insert index, right. So let's go to the graphics. There's 2 things that we do. Bin ellipsoids buffer, bin objects buffer. Yeah, so before we do the splatting, we need to take all of our objects that we want to splat and put the object IDs in this bin objects buffer. Now this is by the maximum number of objects you can bin. So there's 5 bins. So we have a copy shader that's optimal for 4. There's powers of 4. 4, 16, 64, 256, and 256 plus. So we have shaders which are good at copying those many times, or, basically. And the maximum number of objects per bin is actually 60. Right. So we need to make sure we don't have more than that many objects actually, right? So we need to be careful here. Is that really a lot? Like, I saw this number, like, we're gonna probably have more. We should have 256,000 worth of those, I think. And then those get splatted. I've really got to be careful. Yeah, see, there's the million cap, right? We got 1 million, and then it crashed. So you know, so I think we support up to initially 1,000 model instances, but we might need more than that. You know, maybe we should make this number like 256K at least. And then, right, so that was 64 squared, wasn't it? Sorry, cubed. Why do I keep saying squared? I do 3D now. Yeah. So that in our system that we have, yeah, we're gonna go over that capacity still. Maybe we could put 1 million down. And then maybe we could say we swap to 16 million, but that's like what? There's so many megabytes, that should be okay. It's a lot of megabytes. Let's stick with that. So in terms of like the amount of objects that we can sort, yes, the amount of objects we can actually sort is 1 million. So we could swap to maybe 4 million. Let's give that a go, I think. So now we're just going to put some safety checks in the shader code. So there's two places. One, we fill in these bins, which is the amount of the objects that we want to duplicate for every tile they overlap. So that will go into that shaders code again. So calculate insert index for the objects that we want to duplicate, right? So you figure out how many tiles does it overlap, then you figure out which bin it goes into, then we append here. So if we overflow, what the crap is that doing? What should be focus in 3 to 4 months to learn game engine architecture and achieve results? Good question. So you want to learn how to sort of like architect the game engine as a whole, right? How do you structure a game engine as a whole? That's the question, right? Like, you're not really necessarily concerned about under how each system implements, right? Like the nitty gritty of every system. Well, there's many different ways you can architect an engine. That's the thing. But there are main things, right? You want to have like a game thread these days, and a render thread, and then like, or maybe sometimes people do job systems as well, like full-on job systems. And then there's like a platform layer for operating systems. There's like, you know, a renderer, which in of itself is its own big thing. But yeah, what should be the focus to learn and achieve results? I would recommend. See, you're not going to achieve everything in 3 to 4 months, but if you want to learn about making game engines, I would probably start. If you've got some programming experience already, start with SDL2 or 3 these days. SDL3, and probably take use of their new GPU thing. which is abstraction over Vulkan, Metal, and DirectX 12. And this is like a platform layer for both CPU and GPU now. So it does all stuff like keyboard, mouse, and stuff like that. And I would guess, what would you try and do in 3 to 4 months to learn engine architecture? It's quite a difficult thing. So you'd have to use something to get yourself, like STL, to get all the sort of low level bits out of the way. And then you probably would like to It really depends on what you want to learn, actually. Like, what is your hope after 3 to 4 months? Do you want to know all there is to know? Because that's going to be impossible. Do you want to learn a certain aspect of game engine development? Like how to abstract over a platform, or 3D programming for computer graphics. You know, I think you really got to hone in on a particular. You've got to hone in on a particular subset, or maybe you want to be like, how do I put a 2D game together and make an engine for that? Or how do I make a 3D game engine and put a game engine together for that? Right, because they're kind of different levels of complexity. I guess, what is your sort of goal other than learning game engine architecture? Because it's not really possible to do it all in 3 to 4 months, is my concern. What is the bit you're most... What are you trying to achieve from that? You've done a repo from GitHub, I've already set up, by the way. Interesting. Have you got a link to that, Raf? Thank you. If you could link to that, Raf, that'd be amazing. Right, so this doing atomic add the base indices. What's this doing? Base indices. Did I not use the bin index? No way is that a problem. Atomic adder index. I wrote this code, but I don't even know what that means. And it wasn't too long ago that I wrote this code. What did Henry from like a month ago do? Oh, I'm just reusing this for something else, isn't it? Right. Yes, if I'm the first so many threads in the thread group. Gotcha. So with made projects, you can reuse parts of the engines for previous projects into another project. Yeah, that's some good advice. I would recommend that too. Sounds like a good idea. Yeah, just make loads of little projects that are short, like a Tetris clone, then make something that's a little bit more complicated. And you don't have to make it exactly like Tetris. You can always make your own spin on it to make it a little bit more fun. Then learn, take the old end. You've technically thrown away the old code, but you've not thrown it away. It's just off. You're just not working on it anymore. And you take that code and bring it up to the new code base, refactor the crap out of it, and make it for this new project. And that way you're iterating really fast and learning from your past mistakes, because the problem is if you just do a big project is you don't get to sort of fail fast and learn about iterating on your API and critiquing it. You find a lot of people just spend a lot of time on a single project and they don't get to redesign something as basic as a collection class, as people call them. You know, like your dynamic arrays or like other aspects of making a game. Like just designing good APIs. It's a skill which is quite takes a lot of iteration and a lot of learning. Like when you design an API, you actually need to write the usage code. And you think, how am I going to use this thing? And you don't realize that for a long time. Because I think it's probably impossible for you to write an API without using it and be certain it's good. So there's loads of little things you need to pick up on. And designing an API is part of the architecture of making an engine. Just take some projects and change the path to MSVC. Right. Cool. This is SDL2 though. Yeah, it's SDL2 though. Have we said SDL3? Right, so we find next indices based on the number of objects we want to bin. Right. I don't understand what this is doing. I've had to do something a bit funny here where I go over all of the base bin. So what is it adding into? Effectively, this code here is just trying to say, right, for the first like 5 threads which come into here, run this code. But it has to do it in such a way because not all 5 threads could be active. So there's a bit of funny stuff going on. So tile bin, sorry, target bin index. How many are currently in there? Right. Right, so all the threads that come into here across all the thread groups come into here and get their bin index. Each thread's doing this. And then doing an atomic add, getting its relative insert index. And then this is basically Right, then we're taking the objects counts, which we all would have added. So all threads would park here until they've done this. Then 5 threads are going to come into here and generate the base insert indices, right? Okay, I should already comment this because it took me a bit to understand. Right, so all threads bump the objects count for the bin it wants to insert in. Then here we say calculate the base insert indices for each bin. And then this will actually insert all threads the first n threads calculate all the threads calculate their insert index. This goes into the thread group memory, so it's just a way of reducing the amount of global atomic adds, basically. So it's more performant. The LDS objects count. The LDS memory for objects count. Objects count in LDS memory for the bin. In global memory. Into global memory. Cool. Right. So I'm glad I reworked how that works. So what are we doing here? So the base insert indices can overflow. So, sorry, the insert index can overflow. So what we need to say is if the insert index is greater than or equal to the graphics tile bin, objects count, then what you'd need to I guess you can return U32 max to make it a little bit of an easier thing to remember, and hopefully the compiler can optimize that. Well, no, I don't really care. We do it here. So this is, I think, the UI code or the UI top and encode. So if we overflow it, just don't bother trying to render it. Jobs are good. Same here. This is for the ellipsoids. If we overflow it, don't bother trying to render it. Right, so that's our first buffer that we can potentially overflow. So now we're going to take a look at the other one. So that was for the... So the other one is the sort. So these splat object shaders, the issue with these ones, there's many of these, optimized for copying or duplicating references to an object as many times as it goes into a tile, and then calculates the sort key with the tile index in the higher bits and the depth in the low bits. So we calculate this sort of like insert index again. And you know, these shaders were like pretty quick, to be honest, for the amount of objects they were copying. So the problem is this insert index. When the insert index overflows the buffer, so if insert index is greater than or equal to graphics tile bin entries, it's not object entries count, we just did that one. Oh no, it is that one. Yeah. If that is the case, then we break or we return. I'll do a break here. So I think we want to do that for, we'll see, right? Because they're all kind of different. Do it there. So that one's good at copying 4 objects. This one's good at duplicating 16 objects. And we're still at the similar sort of thing here. So keep it going. This one's really good at duplicating 64 objects. So we do have a bit of a safeguard here, but it's still not good enough. Hang on a minute. Sorry. Okay, yeah, sorry, 64. Then I had to forward declare that. Let me get rid of that. Uh, 256 objects. And then 256 plus objects. Cool. So that should hopefully be it. So now we should never overflow these buffers, but when we do, there will be problems. Visual issues, I think. But at least it will not crash. I'm going to rest for a while, maybe just C++ project. Bye. Alright, catch that video. Good to see you. Have a good one. Right, there's already a problem. That's no longer rendering everything. Sad. So we actually broke. We broke something. And I don't know what it was. So what we're going to do is we're going to delete all of these overflow checks and see if there's any. We'll just see if the issue resolves itself. Okay, so apparently it wasn't to do with the fact that we changed some of the size of the arrays. It was clearly to do with there's some overflow going on. So, oh no. Okay, there isn't really overflow going on. I'll tell you what the problem is. So, when we do that sort of tile bin, when we put it in these bins, the problem is base insert index plus relative index. So the issue is that these base insert indices are actually initialized to or the ones in the global buffer, they're initialized to, what's a good way of drawing it? So when we have an ellipsoid, for instance, that we want to draw to the screen, we need to make sure we duplicate it for every single time it overlaps a single tile. So we figure out how many tiles it's going over, and then we say, right, if it's good at filling up 4 of them, it goes into one bin. When it's good at filling up around 16 of them, it goes into another bin. Around 64 goes into another bin. Around 256 goes into another bin. And then everything else after that goes into another bin. So we have these, you bin them into these different arrays, and each of this is fixed allocated and is maxed at however many maximum number. We've got a maximum number of 256 objects. Sorry, 256,000 objects that we can render. And each of these is one big array, but each of these sub-arrays in here is 256,000. So what happens is that let's just find it. There you go. So when we set up the tile binning, we make sure we set all of the bins equal to the offset. So the cursors will start at the start of the bins. So when we bump allocate, we just bump the cursor across. So the problem is the insert index is not a good way to say how many are in a bucket, or sorry, in a bin. Because what it's really encapsulated in there is, it's not a relative index inside the bin, it's an index in the whole buffer. So we're actually stopping it from working at all, basically. So we need to say, so the only ones that will work are the ones that go into this bin, basically. Any ones that go into these bins will not work. So we need to take it away by this base bin index. Now we don't have the bin index outside this function, which is a problem. So what you actually want to say is if insert index is greater than, take this base offset. That's not good. No, there's an offset thing, isn't it? It's a graphics tile bin offset bin index. Right. Now if that is greater than or equal to the graphics tile bin, I don't even know, tile bin objects capacity, then I guess we'll return the E32 max then, right? And then the 2 times this is called, we'll change it to save as equal to E32 max. And then we can just roll with that. Alright. Cool. I'm just gonna get my charger. Right, so the UI is not busted anymore. That's good. So if